Good evening, everybody. Kostas Kontogiannis, I'm a professor at the Electrical Engineering and Computer Science Department here at York University. And I have the opportunity the past year to lead the efforts for two Markham programs. One is the Bachelor's of Applied Science in Computer Science for Software Development, the one that I will be presenting today. And the other one is the Bachelor's of Applied Science in Computer Science for Digital Technologies. I think that we'll have a presentation next week for this program. So I would like to give you an overview of the program, how the program is structured, what its objectives, and what you'll get out of this program. So that when you're applying for your universities, you'll have an educated picture of the different programs being offered. So this is a new program that would be offered in the Markham campus. It's a brand new campus. I was talking today with the dean, and they visited the campus. It's an amazing building, an amazing area. So a brand new building, brand new facilities. And it's a program, think of it as a computer science program with a twist. Here you will learn how to build software systems, large-scale software systems, how to design them, implement them, test them, and deploy them. The difference that you will see with a typical computer science program, even the one that is offered here at Kiel, the Markham program focuses on experiential learning. That means you do a lot of projects and you do a lot of hands-on. So here the program aims to guide you through essentially understanding the core principles of computer science. So after all, it's a computer science program. So you will learn all of the theoretical and core aspects of computer science. You won't be lacking any knowledge of computer science. And then you'd start looking at different designing solutions on how to architect complex software systems. And also, once you do that, by designing and implementing and testing and deploying, you would like to effectively communicate with audiences, your design, your rationale, and so on. So it's not only the technical aspect, but we look also at the professional and communications aspect as well of a software developer. The reason that we thought about this program was an ever-growing demand for technology workers, if you like, technology knowledge workers. And a typical, chart here that you would see on the left side, on the left part, is the billions of dollars in economic and financial activity in the tech sector, in particular technology, IT technology, close to $240 billion, while the ICT in the Canadian employment reaches approximately 3.8% of the total workforce. So 3.8% of the total workforce works exactly in software. And we have a tremendous shortage of technology workers, and a big part of them is IT globally. We're lacking 200,000 positions in Canada in technology, and a big chunk of it is IT. So, driven by this demand, we started designing these two new programs at Markham. So here we'll be talking on the computer science for software development. So, some questions to think about and why software is important. Have you thought of what is behind guiding autonomous vehicles? I mean, AI software, software that thinks and plans and formulates plans and takes actions autonomously. How do we decide where to look for rare minerals and where to drill, right? So there are analytics software which analyzes billions of pieces of data in order to find the best place to drill. Or how do we design new cars or airplanes? Do we do simulations? How do we design new vaccines? We look all possible combinations of and mutations that we can think of with supercomputers and cloud computing in order to come up with combinations that we haven't thought of before. How do we design smart cities, and how do we synchronize, for example, traffic lights? How do we organize traffic in big cities like Toronto or New York or Boston, right? And more exotic, if you like, as a big question is that how doctors prepare for challenging operations, augmented reality, virtual reality. And for very challenging operations of the brain, they create, models of the brain and simulations, and then simulate their operation even before they do it. So then when they perform the operation, they have done it a couple of times on the computer. So all these and many more fuel our everyday lives. I mean, think of what will happen if we didn't have computers for a day. And I'm not talking only TikTok and Facebook, right? So, very basic things like, being able to take the subway. So if I could give you the program structure from 30,000 feet, if you like, the courses are structured in two main categories, what we call the required courses and what we call the elective courses. So the required courses are courses that deal with fundamental and core knowledge of computer science. So here you're getting the core courses of a computer science program, right? You have also several courses, which is mathematics for computer science, like discrete mathematics and so on. And then you have a collection of general education courses like professionalism, ethics, equity, and so on. So these are, courses that they amplify, if you like, your technical knowledge by the professional knowledge. And then you have elective courses, which will be technical courses. These are more computer science courses, like logic programming and functional programming and so on. And then you have, once you finish those, then you have two options. You can go as a honors program, co-op, or you can go as honors with a specialization. And we have two specializations that I will be talking in shortly. So in other words, think about it that you have an option of a 3-year program, that would be 90 credits, and you have the option of a 4-year program, would be the honors program. And in the honors program, you can do a co-op, you can do a specialization, or you can do a combination of co-op and specialization. In order to get into the program, you need to have your marks for 12U English, the advanced functions, 12U advanced functions, and one of biology, chemistry, or physics. And a second math course, even though is not required, is recommended. Okay? So generally, these programs in areas like Toronto, where you have a significant number of applicants, usually these programs attract quite good students. So think to maximize, if you like, your grades on that. I talked about the different options that you have in the program, right? So as I said, you have the option that would be a no honors, that would be a 3-year program, and that would be 90 credits. And then you will have the honors option, which will be 4 years, and it will be 120 credits. Okay. Now, if you opt for the honors program, you can do an honors with specialization, which means that you can take one of the 3 streams, either cloud computing or cybersecurity or data science, or you can do an honors only with co-op by taking courses from any of these streams, or you can do a co-op and specialization. So you have all these possible combinations you can do. I would strongly advise for a 4-year honors because it's a typical program. But we give you the option if at any particular point you realize that you have this amazing idea and have your startup and make millions, probably you can graduate with a non-honors degree. But I mean, essentially, the idea is that you can continue with an honors degree. To give you an idea of the courses that we'll be taking in this program, and this is just a sample, just to see the progression of the courses. The main core of the program, with respect of the core CS courses, so think of the first 3 bullets: the core CS courses, the supplemental core CS courses, and the math and general education. This is practically the non-honors, and this is amplified with more courses to go for the honors. So the core program is core CS courses like introductory programming. We don't expect you to know programming, by the way. So you come to the university to learn. So we don't expect that you are a hackathon winners. If you are, that's a major plus. If not, that's fine. Then you learn about object-oriented programming, another type of programming paradigm. You learn low-level programming like C and assembly. You learn about theoretical aspects of computer science, like the designing of algorithms and analyzing algorithms, their complexity, their performance, and so on. Network-centric computing. How do you have distributed applications and you build distributed applications? And elements of software engineering, like software design, software requirements, software testing, and so on. In the supplemental core CS courses, you take the core, which is a typical core CS program, and you supplement it with the rest of the program to make up a full computer science program, like logic programming, functional programming, programming with multi-core computers, programming GPUs, for GPUs, databases, software quality and testing. Okay, so the first 2 bring up a typical computer science program, and then you decorate that with mathematics and general education courses like general and discrete mathematics, and general education courses like teamwork and communication, ethics, digital citizenry, and so on. So you don't only learn about technology, but how ethically to apply this technology. Now, if you continue with the co-op, also we have courses with respect of preparation for the workplace, which anyone can take anyhow. It's not only the co-op students. Professional development for co-op, that would be more geared for students who opt for co-op, and also critical reflection. And we offer also the possibility of doing an undergraduate research and programming challenges with professors. So if you have some ideas, or if the companies that are in Markham area, they give us challenges and they give us interesting problems, then you can work with a professor to provide solutions to these problems. And of course, you can engage in summer research. We have both NSERC and York provide scholarships for research internships and so on. And of course, if you opt for the honors, which has the 4-year project, 4-year program, then on the 4th year, you can have a capstone project, which would be something that either you can discuss with your professors, or an idea that you may have on your own in order to start your new company. So that's the core, if you like. If you decide to take a specialization, then the part A would be the core, the main BASc honors, which I discussed in the previous slide. And now you have one of the 3 specializations. So you can opt in one of the 3 specializations. If you opt for the cloud computing, the focus here is how to design cloud systems. You are talking about software engineering for cloud systems. You'll be learning and about microservices and containers and serverless computing. How do you efficiently deploy cloud systems? And what will be the DevOps pipelines for that? So what will be the processes for building them, right? And the tooling that you use in order to build them, from compilers all the way to testing, version control systems, and so on. So the cloud computing will make you an expert on designing, testing, deploying, and maintaining cloud systems. The second specialization is about cybersecurity, and we're talking about introduction to threats, forensics, network security, vulnerability detection. So think of this stream as spanning the stack from network security all the way to application security. And the third one is data science specialization, where we're talking about introduction to AI, foundations of data science, which is the necessary math for data science, applied machine learning, which you apply now algorithms and machine learning techniques, and as well as big data analytics, how to analyze massive data sets and draw conclusions from these. So why computer science for software development at Markham? I mean, there are many computer science programs. I would say in the GTA and in an area of Toronto, Greater Toronto area, which I would say it's a focal area for technology, I would say, in Canada. There are several computer science programs offered, right? Why this one? Well, the major part is that you focus on doing things, not only on studying it and with toy projects or toy quizzes. So here you have hands-on experience. So you will be every week you will have projects. You'll be working with your professors on seeing solutions and devising solutions. So it's an experiential learning type of program, and lots of hands-on. There is a close connection with industry. Markham is a hub for high-tech companies in Ontario. Several high-tech companies have expressed already significant interest in our programs. The specialization areas that I mentioned, cloud computing, cybersecurity, data sciences, data science, they were selected because there is a big demand in the industry right now for this one. And the program offers a unique combination of theoretical and practical knowledge. So you have a full knowledge of any typical computer science program, plus the hands-on experience. So, and that was our main focus designing this particular program. So how would you place yourself? I mean, if I look back 10 years ago, and I would say that, well, many things have changed. So with respect of cloud systems, well, at that time we had virtual machines, practically virtual computers that we could deploy. Amazon and IBM and Microsoft started providing, some cloud solutions. When we're talking about intelligent applications, we're talking about analytics, basically big data analytics, and cybersecurity threats were orders of magnitude, simpler than the ones are today. Where we're heading in 10 years from now, I mean, it's difficult to tell with technology and how fast it advances. But if I could make a guess, we'll have a massive deployment of microservices and agent computing, so small components that interact with each other to make large applications. Internet of Things, connected devices, smart cities, intelligent management of resources like energy resources or waste or water resources and so on. Artificial intelligence and ethics. And how we apply artificial intelligence. Even though probably in 10 years from now, we may not have reached singularity, I'm not sure, might be, but well, I hope not. We're heading definitely there. For cybersecurity, we start seeing applications where intelligent agents protect our systems. And of course, we have human-machine communication. We have devices which are connected to the human body to help, people with disabilities, vision, and so on. So these are some areas where I see coming very strong, and this program caters to solving, if you like, the software aspect of these problems. Now, where can you work by having this program? So first of all, as a software developer, okay, or software architect. So software architect, you'll be achieving this stage when you work for some years. As a data scientist or a data analyst, cybersecurity analyst, e-commerce developer or architect, cloud architect, IT project manager. So I would say a graduate from this program, if they work in the software industry, most likely will be engaging on designing and implementing large-scale software systems. If they go and work in, say, in the finance sector, most likely they will be architecting cloud solutions, data management, data science, machine learning, and so on. If they go in more to an engineering firm, they will be working as systems analysts, deploying large-scale cloud systems, and so on. So here you're getting significant practical experience, as I mentioned, because of the experiential learning, which is a major component of the program. The co-op, so you can imagine that you have experiential learning for 4 years, and at the same time you have, your co-op. You have a capstone project, which is a full year, grants throughout the year. And then you have an undergraduate research opportunities every summer. So, I mean, it's a tremendous volume of hands-on experience that you're getting here in this program. Some final thoughts. Actually, I was curious, and I was thinking, Silicon Valley is the center of IT. And in my mind, always, Silicon Valley was a huge area. So practically, it runs north to Redwood City, up until south to Los Gatos, and west from Portoa Valley to pretty much to Milipitas. So this is the area of Silicon Valley. Now, if you project this area in Toronto, we're talking about a little bit east of Markham, up until 427, and from Toronto in the south, Toronto downtown to Richmond Hill. So that's Silicon Valley. In Silicon Valley, we have 500,000 people working in IT. In this area, in the corresponding area in Toronto, we have 250,000 people. So you can imagine here, I mean, there is tremendous activity in the area. And essentially what we're trying to do, to cater to this expanding technology area. So you get a solid computer science bachelor with a major practical component, experiential learning, co-op, undergraduate projects, capstone, and so on. You connect with industry. You have a very thorough preparation of succeeding in your career. And you can either get into the workforce after graduating or continue for a graduate degree. So it's a bachelor's of applied science. That means you can continue for a master's, and for the brave ones, even a PhD. So that pretty much, I hope, gives you a top-level view, a high-level view of the program. And if I could have a very final, if you like, pitch on that, it would be like, it's based so much on experiential learning that you do a lot of programming in this program. Okay, So with that, I hope you got an idea, and we're looking forward to seeing your application and hopefully seeing you on campus.